Welcome to Harrison and Ian's classroom. Today we're going to be going over lessons 9.4, 9.6, and 9.7. First we're starting off with 9.4, the compositions of isometries, and here's the vocab. First we have reflection, and a reflection is the opposite image moved across the y-axis. And then we also have a glide reflection, which is a reflection where you also move the image up or down the y-axis. Four theorems. Theorem 9.1. The composition of two or more isometries is an isometry. 9.2. A composition of reflections across two parallel lines is a transformation. 9.3. A composition of reflections across two or more intersecting lines is a rotation. For practice problem number 1. Here in black we have the original image that we're going to be reflecting and translating today. And in red we have the reflection line, which is 3, and that's the line we're going to be reflecting across. And then T is the translation, and we're going to be moving it 2 to the right, and we're not going to change the point on the y-axis. So for number 1, to reflect it, we're going to, it's one space away from the red line, so we're going to multiply that by 2 and add it to the y-axis. So when you multiply it by 2, it is 2, and 2 to 2 is 4, so that's going to be the y point. And the x-axis is also 2, so we're going to add 2 to that, and that comes out to be 4 also. For B, it is -2 on the y-axis, and that is 5 away, so we're going to multiply 5 by 2, which will be 10, and then 10 minus 2 is 8, and that is the y-axis, and then it is -1, so we're going to add 2 to that, and it turns out to be 1 for the x-axis. C is -1, and that is 4 away from the red line, so 4 times 2 is 8, and so that is -7, and then 4 plus 2 is 6, and then we are going to graph that. So for 4, this is A. B is 8, 1, and then Y is 7, so 6, 7. And that is the reflected and translated image.
Hi, I'm Harrison Weil, and I'm going to be doing lesson 9.6, which is dilations. So we're going to start off with the vocab first. The first vocab word is dilation. A dilation is a transformation that has center C and scale factor n. If n is greater than 1, the dilation is an enlargement. If scale factor n is greater than 0 but less than 1, the scale factor is a reduction. The next vocab word is scale factor of a dilation, and that is the ratio of the distances from the center of dilation to an image point to its pre-image point. Okay, so practice problem number 1 for lesson 9.6 over dilations. Find the image of point D2, and then for the coordinates 1, -5. So for this problem, the scale factor is going to be the 2, so that is right there. So since the scale factor is 2, you're going to multiply both these numbers by 2. So the image would be 2 and -10. That would be the image for this dilation. This is practice problem number 2 for lessons 9.6 dilations. The blue figure is the dilation image of the black figure with center of dilation C. Is the dilation an enlargement or reduction? What is the scale factor of the dilation? Okay, so for this problem, it's asking if it's an enlargement or a reduction and what the scale factor is. So the first thing we have to do is to find the scale factor, so that way we can figure out if it's an enlargement or reduction. So to figure out the scale factor, you're going to take the new point of dilation, which is 12, and you're going to divide it by the old one, which is 8. So then we're going to reduce that by 4, and that equals 3 over 2. So then the scale factor equals 3 over 2. And since 3 over 2 is greater than 1, the scale factor is going to be an enlargement. And that's the answer. Alright, this is lesson 9.7, similarity transformations, and I'm going to be starting off with the vocab. The first word is similarity transformation. Notice a composition of a rigid motion and a dilation. The next vocab word is similar figures. Similar figures are two figures that have the same shape but not necessarily the same size. And two figures are similar if and only if there is a similarity transformation that maps one figure onto the other.
Similarity transformations, problem 1. Here in black we have the original figure, and we're going to be reflecting that across the x-axis and then dilating by a scale factor of 0.5. So first thing, you reflect across the x-axis, which is pretty easy. You just change the y value to the opposite. So for point A it is -2, and we're just going to change that to +2. You keep the x value the same. And then for B, it is -5. So we're just going to go to +5. And then for C, it's -2 again. So you're going to do +2. And then that will be the reflected image. And then you also have to dilate that by a scale factor of 0.5. So you just divide every value by 2. And so A is 6, 2, so that would be 3, 1. And then C is 1, 2, so that would be 0.5, 2, 0.51, I mean. And then B is 4, 5, so that's going to be 2 and 2.5, 2, 2.5. And then the blue figure is your final image, answer. All right.